Hi, so today we're going to look at the Pythagorean Theorem. The Pythagorean Theorem describes the relationship between the length of the hypotenuse and the length of its legs. The first thing I do want to bring up, and it doesn't actually say this here, it does show it in the model, and it's really a key portion of what we're going to do today. But the Pythagorean Theorem deals with only right triangles. Okay, and that's really important. Not acute or obtuse, only right triangles. And what the Pythagorean theorem does is it helps you find a missing length. So if you know two lengths of your triangle, it's going to help you find the third length of your triangle. And again, it's only for right triangles. So let's talk about when it says the hypotenuse and the length of the legs, what that actually means. And the easiest way to do that is to go ahead and look at the model over here on the right-hand side. A and B, these two sides right here, these two sides make up the legs of the triangle. The legs of a right triangle form the right angle. So if you can find the right angle, which should be easy to do, that's that 90-degree angle, the two sides that make that, those are your legs. And you can reverse those and say this is A and this is B, or vice versa, B and A. What's important that you do is you make sure that A and B are always the legs. C is always the longest side. Okay, it's always the longest. And C is always the hypotenuse. I'm just going to abbreviate that. C is always the hypotenuse. It is the longest side of a right triangle. Another way to always be able to find the hypotenuse is it's always opposite of the right angle. So if you find the right angle, opposite of that is always the hypotenuse. So for an example here, it says to find the length of the hypotenuse. So we're going to start with the Pythagorean theorem. The Pythagorean theorem is right here, that very first one, and that is a squared plus b squared equals c squared. A squared plus b squared equals c squared. Remember, a and b are the legs, and c is the hypotenuse. So if we square the legs and add them together, that will equal the square of the hypotenuse. And we're going to be using our knowledge that we learned yesterday on squares and square roots today. So we start with the Pythagorean theorem, which is a squared plus b squared equals c squared. We fill in what we know, and looking at our picture to the right, I know the two legs. I know the 4 and the 8, so I'm going to fill those in. And it doesn't matter if you do 8 squared plus 4 squared or 4 squared plus 8 squared. That does not matter. We end up squaring 8 and 4. We get 64 and 16. Add those together and we get 80. So if you notice right here in this step, we have that c squared equals 80. Now you're not done with the problem because we don't want to know what c squared equals. We want to know what c equals. So we have to get rid of the square. And how do we get rid of a square? That's right, we do the square root. So I'm going to have to take the square root of both sides. That leaves me with just c. And then the square root of 80, unfortunately, that's not a perfect square, and they ended up using your calculator. You'll see more perfect squares than you will see imperfect squares. But in this example, the square root of 80 is about 8.9. Try another one. Here we're going to be finding the missing leg, and if you take a look at the picture, here's my right angle. That's my hypotenuse. Here's one leg, here's the other leg, and you can tell this is the side I don't know. I'm going to find that missing leg. So just like we did before, start with the Pythagorean theorem. A squared plus b squared equals c squared. Fill in what we know. We know the hypotenuse is 13. We know one of the legs is 5, and we're trying to find the other leg. So I'm going to leave that other leg as b. Let's square everything we know. So 13 squared is 169. 5 squared is 25. Now at this point right here, we're trying to solve for b squared. If you remember from the other example, here's where we added our two legs. Well, in this example, I'm going to subtract 25 from both sides. That leaves me with 69 minus 25 is 144 equals b squared. And just like last time, you'll always end these questions with taking the square root. We'll take the square root of each side here. The square root of b squared is b, and the square root of 144 is 12. So the length of that missing side is 12. All right, let's try these 3 quick examples. It says to find the missing measure of each triangle, round to the nearest tenth if necessary. All right, so let's look at this first one. I'm going to start with my equation, a squared plus b squared equals c squared. And we're going to fill in what we know. We have a missing hypotenuse. We know our legs. So 14 squared plus 8 squared equals c squared. So at this point, we're going to actually square these. And again, if you know these already, that makes it easier. If not, you'll have to go over to the side and just do some multiplication. So 14 squared is 196, and 8 squared is 64, and that equals c squared. At this point, we will add 64 and 196, and we get 260. And unfortunately, this is not a perfect square. So this is one of those questions. It does tell us here to round to the nearest tenth. I'm not going to have y'all do that. I'm actually going to have y'all do what we did yesterday, and that is pick the 2 that it's in between. And for us, this one is in between 16 squared and 17 squared, where 16 squared is 256. And 17 squared is 289. So it's in between 16 and 17, and it's closer to 16. So we're going to say that our missing side is about 16. It's not exact, but it's about. All right, let's try letter B. So we've got a squared plus b squared equals c squared. And again, I've got a missing hypotenuse, so let's plug in. We've got 21 squared plus 28 squared equals c squared. So we're going to actually have to square these 2 numbers. 21 squared is 441, and 28 squared is 784, and that equals c squared. Now we're going to need to add those together, which is 1,225. That equals c squared. And now remember, we want to undo that square, so we want to take the square root of each of these. Well, the square root of 1225 is 35. So 35 equals c. This one was a perfect square. We don't have to do anything else with that one. Okay, and this last one, we've got a squared plus b squared equals c squared. Let's plug in what we know. This time we're missing a leg. We're missing a. So I'm going to leave a squared here. I'm going to add b squared, which in this case, our b squared is 5. And our c, our hypotenuse, is 15. So now let's actually go ahead and try to do some of this. So I've got a squared plus 25. And I'm so sorry. I feel like my screen is getting too big or too small here. And then 15 squared is 225. So at this point, I'm going to subtract 25 from both sides. So a squared equals 200. So now we've got to think if the square root of 200 is a perfect square or not. And it is not. So I'm going to try to think what it's closest to. Well, it's closest to 196, which is 14, and 225, which is 15. And we want to think which one is it closer to. So it's actually closer to 14. So our answer is somewhere between 14 and 15. So I hope this was helpful. Just take your time, remember your squares and square roots, and y'all will do great. Tomorrow we're going to look at some applications, so you're going to get more practice with the Pythagorean theorem tomorrow.